Hello and welcome to a new session of data visualization using the Seaborn package. We already seen the visualization using matplotlib. Along with the matplotlib, one more package like Seaborn we can use to visualize your data in multiple ways. The advantage is that the Seaborn contains inbuilt ability to visualize the multi-dimensional data set. Multi-dimensional, two-dimensional basically, which contains multiple columns like data frame. So whenever data frame visualization is expected, we are going to make use of the Seaborn package there effectively. So let's see how to work with the package Seaborn. In real world analytics, the best way to get insights is by visualizing the data. By visualization, we can easily show you the results, easily find the insights in the data. So it's very important to use different kind of the plots and check how the data is deviated, how the data is actually stored, and how the results are generated. So data can be visualized by representing it as plots, which is easy to understand, explore and grasp. Such data helps in drawing the attention of key elements. To analyze the data using Python, we can make use of the matplotlib package, which is implemented for 2D plotting. Likewise, Seaborn is also one of the best library for visualization of data in Python. It is built on the top of the matplotlib. Now, if we compare the Seaborn with matplotlib, like it is summarized that if matplotlib tries to make easy things easy, hard things possible, Seaborn tries to make it well-defined set of hard things easy too. So, Seaborn helps to resolve two major problems faced by matplotlib, and these problems are like default matplotlib parameters and working with data frames. As Seaborn complement and extend matplotlib, the learning curve is quite gradual. If you know matplotlib, you're already halfway through the Seaborn, because it's very connected kind of graphs are possible there, and easy way to visualize this particular data is possible using Seaborn. What are the features that Seaborn is having? Now Seaborn is built on the top of Python's core visualization library matplotlib. It is meant to serve as a complement, not a replacement. However, Seaborn comes with very important features. Let's see some of them, like built-in theme for styling matplotlib graphics, visualizing univariate and bivariate data, fitting in and visualizing linear regression models, plotting statistical time series data. Seaborn works well with NumPy and Pandas data structures also. It comes with built-in theme for styling matplotlib graphics. In most cases, you will still use matplotlib for simple plotting, but the knowledge of matplotlib is recommended to tweak Seaborn's default plots. Okay, so how to install? Let's use the installation methodology. First, you can use pip installer, by which sudo pip3 install Seaborn. You can use the Seaborn by using this particular command, or by using anaconda, you can use conda install Seaborn. Okay, so basically it's required that Seaborn should have Python 3.4 plus package, NumPy, SciPy, Pandas and matplotlib installed already on your system. So it works fine and well also with all of these packages. Okay, so if you install that, let's start working practically with the help of Seaborn. So before actually starting, Seaborn contains one ability just like data frames, Pandas. It inbuilt contains some packages to practice. Okay, so if you want to get these package names, we can just check this how to use it. So Seaborn contains an alternative name as SNS. Somewhere we can find SB also, but very regularly data scientist uses the name SNS for Seaborn. So let's import the Seaborn here. Let's import Seaborn as SNS. Now, so inside SNS we are having a function called as get dataset names. So with the help of get dataset names, we can find the names of the inbuilt data set that Seaborn is containing. Let's see which packages, which data sets are present over there. Okay, and out of it, some of the data sets, 4 or 5 data sets I'll be using throughout this particular session for data visualization here. So check out the data set names here. Okay, so this data set names will carry all the names of it. Okay, check it out. So these are the commonly used data set which we can make use of it. Out of it, Iris very commonly is, which we might be knowing, or Titanic survival data set is also present inside, or MPG. This data set is also present in it. Okay, so and if you want to use this data, like I want to use Iris now, so To use that one, I can use sns dot load dataset and give the dataset's name as iris. This dataset will be loaded into data frame, and if you want to print that, you can make use of this. See this one, df dot head, exactly in the same way that if you want to print a snapshot, first 5 entries of the data frame, I will be making use of this method, df dot head. Okay, so we know the iris dataset already. These are the dimensions of an iris flower, sepal length, sepal width, petal length, petal width, and based on that species, the last output column is defined. Now let's use this and perform the operation on this dataset. We'll be using few more also, like we can use the exercise. I'll be using tips, I'll be using Titanic. This dataset also we are going to make using the upcoming some of the topics here. Okay, so let's start with the first. This is data pre-processing task that we can do by visualization, like univariate distribution. Now univariate means single, so distribution of data is the foremost thing that we need to understand while analyzing the data. Here we'll see how the Seaborn help us in understanding the univariate distribution of the data. Now the function univariate single distribution of single variable distribution data that we can find by using the function called as Distplot. It provides the most convenient way to take a quick look at the univariate distribution. This function will plot histogram that fits the kernel density estimation of data. Okay, so histogram, we already came across. Histogram is a frequency plot by which we can find the distribution of the data. So let's go and check the histogram first. So histogram represent the data distribution by forming bins along the range of the data and their drawing bars to show the number of observations that fall in each bin. So let's see how histogram is identified. So for using histogram, I'm making use of the Distplot function here. So first of all, I'm importing matplotlib.pyplot. So from matplotlib, I'm importing pyplot as plt. Okay. After that, I will be loading the data set here, load data set iris in the data frame df. And now let's use of Distplot. As I told, it is univariate distribution, so single columns distribution histogram we can find by this. So sns dot distplot df of petal length. So distribution of petal length I'll be finding by using kernel density estimation is not given over here. I'll show you how exactly the kernel density estimation is possible over here. So let's run this, check it out. So in petal length 1 to 2, this number of elements are there, then 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. So their counts are shown over here, how many are present. Okay, so distribution plot. Even if you don't write plt.show, it's also okay. Directly it will show the plot. So whatever the distribution plot is shown over here that we can see. Okay, so I'm not using KDE. So KDE I'm making false over here. Okay, and if I want to show that KDE, kernel density estimation, so that's also possible to use it there. So what do you mean by kernel density estimation? It's a way to estimate the probability density function of continuous random variable and used for non-parametric analysis. Setting hist flag to false, and this plot will yield the kernel density estimation plot. So let's see this one, how to check it out. So this is kernel density estimation plot. Okay, so you can check out the variations of this. So basically, see, this histogram is converted into the wave format. See, you can check this one. So it's converted like okay, so I'll just combine both together, then we can make use of it. So if I make this parameter hist equal to false, and automatically KDE plot, that is kernel density estimation plot, will be shown by this particular method. So sns.distplot, I'm using petal length, and if I combine them together, I combine them means I will not use any one of these values. By default KDE will be true, hist will be also true. So what will happen in that case? So for this case, so this is what we are using KDE, and now let's use SNS again. Petal length, I am not using any parameters, so by default hist will be true and KDE will also be true. Okay, so let's combine them together, check it out. Now see how they are connected. So kernel density estimation will show the variations in the form of the waves, how it's incrementing, how it's decrementing, means in which particular range is having the lowest value. So check it out. So here I just having maximum variations, maximum values are lying from 3 to 6 almost. That's why this is very high, and very less number of values are present between 2 to 4. That's why this is the lowest part of it. That's what we consider KD, kernel density estimation. If you combine them together, how these variations varies within the data can be shown with the help of this particular graph. Okay, combining distribution KD as well as histogram, both are possible with the help of the Distplot function here. Okay, this is what single variable distribution we can see. Now if we want to see the bivariate distributions, bivariate will contain two parameters. Now it is to determine the relationship between two variables. This mainly deals with the relationship between two variables and how one variable is behaving with respect to other, that we can find. Just like relationship can be found in the form of a 2D plot. The best way to analyze bivariate distribution in Seaborn is using the Joinplot function. The Joinplot creates a multi-panel figure that projects the bivariate relationship between two variables and also the univariate distribution of each variable on the separate axis. So let's see how exactly this will work. Joinplot. Now here also I'll be using the iris, and the function that SNS contain is a Joinplot here. Now as it is used for a bivariate distribution, so I'll making use of X side petal length, and on Y side I'll be having petal width. So petal length against petal width of the iris flower. So here I will be making use of the data frame DF, which I have read from the iris. Okay, and then show you. See this one. Now this is bivariate distribution. You can check this. On X side I am having petal length, Y side I am petal width. Okay, and see how they are connected. So these values which petal length start from 1 to 7 and petal width start from 0 point something to 2.5 in that range, and then accordingly they are plotted. So similar kind of operation in matplotlib is possible with the help of a scatter plot, but here the difference is present. You can check this. These variations are shown in the form of a histogram on X axis and on Y axis. Say this one. So very less number of values are there in between, so they are not present over here, that we can find here in this side also. Check this, how many values are lying within this range, that you can find. How many maximum values are here, so check it out, here also and here also. So this is how bivariate distribution with scatter and histogram, both we can combine together with the help of the Joinplot. So it's very easy and useful method that we can use over here to visualize the data into the bivariate format. So their variation, their connectivity, their relationship we can find by the Joinplot. Now let's use one more plot which is used for the bivariate distributions, called as Hexbin plot. Hexagonal binding is used in bivariate data analysis when the data is sparse in density, that is when the data is very scattered and difficult to analyze through scatter plots. In that case we are going to make use of the Hexbin plots. In addition, we called a parameter, in addition to the parameter kind and value Hexplot is used in the Hexbin plots. So let's see how to use this one. So check it out. Same data set I'll be using here, and parameters are same, only the difference that I'm getting over here is a kind. Joinplot itself is used, but its kind is hex. Okay, so if I run this code, say this one, this is your Hexbin plots. According to the color code, you can find how many values are lying in that particular range, or how many maximum value connect, where the strongest connectivity of the data set is present. Where it's present? Here. Where the lowest is there? Here. See this one. It's very less number of values, even almost 0 values are present over there, that we can find by using the Hexbin plot. This part is same, only the data distribution in the area that can be found with the help of these hexagons, which we can see over here with the help of the Hexbin plots. Okay, so kind we need to mention there is equal to hex, and if you want to add the kind as KD to the Joinplot, that is also possible. This also distribution from kernel density estimation is possible. So we can make use of the kind equal to KD in the same function, in the same data set I'm using over here. I'm making use of the kind equal to KD and check out the kernel density estimation now. See this one. So here how these variations of the data is present, just inverse to the histogram. We have seen KDA plots, and KDA plot we can do with the help of this. So here also very high amount of data is present in this range, and here also very high amount of the data is, and then it's almost decrementing like this. So that's what the density of the data within a specific area that we can find by this particular method, by making joint plots kind type is equal to KD. Okay, so this is how the bivariates are there. Now we can plot bivariate with pairwise relationship. Data sets under the real time study contain many variables. In such cases, the relationship between each and every variable should be analyzed. Okay, so plotting bivariate distribution for N2 combinations will be very complex and time taking process. To plot multiple pairwise bivariate distribution in a data set, you can use the Pairplot function for this. Okay, so this shows the relationship for N2 combinations of variables and data frame as a matrix of plots, and the diagonal plots as a univariate plots. So let's use the function Pairplot. So this Pairplot function contains many parameters. You can check it out. Seaborn.pairplot data for data frame, then view, so a variable to map plot aspect to the different colors that we can use, palette, which colors we have to use, then kind, so two kinds are there, scatter plot and regression lines, and the diag_kind, here also we can use histogram or KDE, and based on that the plot can be visualized. So let's see how to use Pairplot. Now for this particular element, okay, so I'm using again iris, and I'm setting the style of it as the ticks. Okay, and let's use the Pairplot now. Now here the whole data frame I'm passing there. Okay, view is the species, so species is my output variable which I'm keeping view over there. Then kind is KD, kernel density estimation. Okay, diagonal kind is scatter plot, and palette I'm using HUSL. So any default palette can also be used, not compulsory to pass the parameter there. Okay, and now let's see how exactly these pair plots are visualized. So output variable is species. Okay, and all are the input variables. We know that, we are already knowing that output variable is a species in this data set, and 3 input variables are there. So 3 will be plotted now. Let's see how exactly this is possible. Now we can check it out. No, sorry, 4 are there, not 3. This is petal width, petal length, sepal width, sepal length, and against sepal length, sepal width, petal length, petal width. Okay, so they are plotted. So total 4 by 4, 16 plots are there. And check the output variable which I keep is species. This is first color, that is your pink color is showing setosa, green color is showing versicolor, and the blue color is showing virginica, and based on that you can see this graph. So for example, just focus on this particular plot. This plot is sepal length against the petal width. See, so these are the setosa, these are the versicolor, these are the virginica. Okay, if you go to check it out, this sepal width against the petal length, like sepal width against the petal length. So in this plot, all these are the setosa, this green are the versicolor, and these are the virginica. Okay, so in this way we are going to have the connectivity relationship between these two. And if you compare like sepal length against the sepal width, okay, so this is diagonals kind, KDE, I'm using kernel density estimation. So here in this we can check, this is setosa's density, this one is the versicolor's density, and the last one is the virginica's density. Okay, so how these densities are estimated, they are present in this particular column, we can find with the help of KD. So diagonals kind is KD, which I kept over here. So at a time, relationship among all of the input variables can be seen by the Seaborn pair plot here. It's very interesting and very important function which we can use into the bivariate analysis, and by this we can find which variables are actually separating the data most perfectly in case of classification kind of data set. So you might be knowing this data set is coming under the classification category. That is, 3 classes are there, and you can easily see how these classes are separated and how it's possible to separate this data with the help of the input features. Okay, so this is how the pair plot actually functions. Now let's go for the categorical plots, more focusing on that. The scatter plot, Hexbin plot and KDE plots were used to analyze the continuous variable under study. All the values are in continuous, means they may start from any value in negative or any value in positive, any things are possible there. These plots are not suitable for the data when it is categorical, only just like I'm having only 1, 2, 3, or I'm having only 2 categories like male or female, or I'm having 3 classes, first year, second year, third year, like only that things are present. In that case, this data is not suitable. So one or both variables under study are categorical, then we can use the plots like strip plots and the swarm plot. Okay, so Seaborn provides the interface to perform these operations also. So let's see the first categorical scatter plot, that is strip plot. So strip plot is used when one of the variable under study is categorical. It represents the data sorted order to any one of the axes. Check this one. Okay, now let's see how to use it. So let's use iris. Now strip plot, x, that is your output variable, is species, that is categorical. Remember, species is categorical. 3 species are there in this variable, that is setosa, versicolor and virginica. Okay, you have to plot it against what? Against the petal length from the data TF. And now let's see this one, strip plot. Yes, so setosa's range is this. In case of petals length, they are there. Versicolor species are this in the petal length, and virginica species are this. So you can find that actually when the value of petal length increases, species changes. So setosa is the lowest petal length, versicolor is a medium petal length, and the virginica, this one, is containing highest petal length. So categorical against the continuous variable is possible with the help of the strip plot here. So we can make use of this strip plot by this mechanism on what we require on x-axis, what we require on y-axis, and from which data frame we are going to make use of this particular data. Okay, so there is one more parameter that we can use, like jitter. Jitter means the variations that we can remove, and single line is possible, just like the thing which I have shown over here. So in the same function, I am making jitter equal to false. Okay, here jitter is equal to false. So you make it false. So the distribution on the categorical variable will not be shown. So here distribution on this is not shown there. Distribution on the continuous variable is shown only. So start from here to here, start from here to here, from here to here, like only that is possible and present over here by making the jitter equal to false. And now the second kind of the plot is called as the swarm plot. So another option which can be used as alternative to jitter is called as a swarm plot. This function position each point of scatter plot in categorical axis, thereby avoiding the overlapping points. So see this one, this is what the swarm plot is present there. Okay, so what we have, x, these are the species, and their distribution is present like this within this range for petal length, within this range versicolors, and for this range it is for virginica. Okay, so in this way swarm plot can be used. Check it out. Okay, so very commonly used plot which we have which we can use this plot on Matplotlib, and this plot is available for the pandas also. Its name is boxplot. So boxplot is a convenient way to visualize the distribution of data through their quartiles. So boxplot usually have vertical lines extending from the boxes, which are termed as whiskers. These whiskers indicate variability outside the upper and lower quartiles. Hence, box plots are also termed as a box and whisker plot and box and whisker diagram. Outlier detection is very commonly used method applied by the box plots. Any outlier in the data are plotted as the individual points in the box plot. So let's see how exactly box plot will be used here. So Seaborn contains the boxplot function to plot the data using the boxplot format here. See this. So I'm using iris, then again x species, y petal length, and data is equal to df. So same way that we are going to make use of it here. See this one. So for this case, so we are having Setosa's range in this, then versicolor's range is this for range is this for petal length, and Virginica's range is this for the petal length. So this line will show the median values of all, okay, and the points that we can see over here, this one, okay, maximum values are in this range, maximum, and actual range is from here to here, and this point is what we call as outliers. In outlier detection and removal also, we have seen this method, which is not following the criteria or categories of the group. Okay, they are not following the properties of the group. They are far away from the group. In that case, these things are considered as the outliers. So here also we have the outliers. See this one. So the ranges are different. So one categorical against another continuous. This kind of the plots are possible with the help of the box plot methods. Okay. So this is how the box plot method is possible, and we can make use of it to show categorical variables against the continuous variables. Now let's see the violin plots. Now violin plots are the combination of the box plot with the kernel density estimations. Okay, kernel density estimations. So these plots are easier to analyze and understand the distribution of data. Let's use the tips data set to learn more about the violin plots. These data set contain the information related to the tips given by customers in the restaurant. So let's see this one. So first of all, I'll be loading the data set tips here. So check it out, tips, and then check it out. So total bill is this, and tip given by the customer is this. Okay, so the customer's sex, that's whether it's female or male shown, then where is the smoker, on which day, what was the time, dinner or lunch or breakfast, and the size, how many people were present, that size is shown over here. Okay, so that's what the tips data set is present. Okay, and we'll be working visualization on this particular data set now. Let's see. So let's load this data set, and on X side I'll be having a day, that is Sunday or any other day, and on Y side I'll be having a total bill. So day against bill, that I'll be showing in the violin plot. Now let's see this. How exactly? So see this, Thursday, okay, so total bill, so maximum bills were there within 20 to 20th range. Okay, on Friday again check it out, maximum again at the same range again there, and on Saturday we can see maximum again there are in the same range, but some bills were present above 50 also, or more bills are there in 30 to 40 also, like in this way you can see. On Sunday maximum were again from 20 to 10, and then check it out, the relationship. So this is what we call as the violin plot. Okay, this is violin plots, that's we can see. So the quartile and whisker values from the box plot are shown inside the violin. So you can see inside the violin these are shown. So this is what we are having the actual middlemost values present there. Okay, as a violin plot is a KDE, the wider portion of violin indicates that higher density and narrow region represent low densities. Okay, that's what we can easily identify from there. The interquartile range in the box plot and higher density proportion in the KDE fall in the same region of each category of the violin plots. The plot in this particular slide, previous slide, is distribution of total bill for 4 days of the week. This we can see here, 4 days of the week, that we can see how the total bills were there, and what's the density of it. So highest density that we can find from 10 to 20 only, almost in all the days of the week. Okay, we can check it. So this is what a violin plot will show you. Okay, and if you are using the view, okay, by again one more parameter I will be passing, like I am passing parameter sex there, whether the particular person is male or female, that also we are passing there. See, so here I am passing u is equal to sex. Okay, so male and female will be separated. So this is male, these are females, again male, female, male, female. So you can just check it out, which particular gender people are spending more, or they are having maximum number of time they are visiting on your hotel or in your restaurant. Okay, that we can find. So we can on Friday there's a huge difference there. Okay, so female has spent more than the male. Okay, here in this density is more, but some male has spent almost 50 or 40 also, where the female have not spent in the Friday. Okay, so this is how we can make use of the violin plot with the help of the view. Now let's go for the bar plots. So very interesting and very commonly used plots that we use. The bar plot function shows the relationship between categorical variable and continuous variable. Again, the data is represented in rectangular bars, where the length, the bar represent the proportion of the data in the category. The bar plot represent the estimate of central tendency. Okay, so let's use this one. So for this data, we'll be making use of the Titanic data set, Titanic survival data set. Okay, those who have survived or not survived, so their information is maintained inside the Titanic data set. I'm loading that SNS dot load data set Titanic and TF. So let's see this one. There are multiple columns present inside it. Okay, so this is the gender, sex of it, age, then few parameters which you require, like alive or not, alone or not, or who is that, man or woman. Okay, so same are there, who and sex, so man and male and woman and female. Survived or not, that's also shown there. Okay, same parameter again, alive and survived are same. Okay, but doesn't matter, we are going to make use of it here. Now let's use a bar plot. So for what? Sex against the survived, and view is class. So I'm using SNS dot bar plot. X side we have a sex, male or female, and Y side whether it's survived or not, that can be seen here. And view is focusing on a class. Let's see. So here the three classes are there, first, second and third, for a particular person who is survived or not survived. See, so male. Okay, so three categories: first class male, second class male, third class males. And for female, again first class, second class, third class. More females are there in the classes, all the Titanic ship over here. Okay, and see this one, how they are actually the bars are shown here. Okay, so I'm using class as view. See, and these are the survived person. So more number of females are survived than the male, that we can find from this, and more number of first class survivors are there than the second or third class. So third class survivors are very less for both these categories, and even males are very less. Female are more survived than the male. So this is the bar plot that we can use from the SNS bar plot function. Okay, count plot, very interesting. If you have worked on some of the functions, some of the algorithms of the categorical, like when you're using classification algorithms, in that case the output variables count we can find with the help of it. Now for example, let's see the count plot. So here I'm loading a data set Titanic again, and a count plot for class. Okay, for class, let's see this one. For how many survived persons are present, and how many persons are actually present in that. First class persons were almost 200, second class persons were almost 180, and third class were almost 450, or sorry, 480 something like. So in this categorical variable, class categorical variable, how many categories are there? 3 categories, and in these 3 categories, how many persons or how many information, how many tuples, how many rows information is present there, that we can find. First class are this, second class were there, and third class are this one. Okay, so you can use this palettes over here. So let's use greens palette. See. So it depends. So based on the density, based on the values, basically their color variations will change into the count plot. Okay, it's very interesting to see that how many categories are, how many values are there present in a particular category in the classification data set. We can use the count plot function there. Now let's use a point plot. So point plots serve same as the bar plots but in the different style. Rather than the full bar, the value of estimate is represented by a point at a certain height of the other axis. See the output of it. Same which I used here, bar plot, I'll be using, make use of in the point plot here. See, this is what we call as a point plot. Okay, see, what's the range of it? Female to male, their combination that we can see. Okay, first class, this is second class, this is third class, and these are the male. Okay, so in third class, in second class, in first class, which were survived, that we can find with the help of a point plot. This is point plot. So basically, point plot with wide form of data, that's also possible. It's always preferable to use long form and tidy data sets. But at times when we left with no option, rather than to use a wide form data set, some function can also be applied to wide form data in variety of formats, including pandas data frame or 2D array into the numpy. This object should be passed directly to the data parameter, and x and y variable must be specified as strings. See this one, how to use it. Okay, see this. Here I am using the point plot in the wide form format. Okay, so just make use of it here. I am using a function boxplot for this. See, sns.boxplot, data is df, orientation is f or h given over here, and now we can see, so all of these four are given as input. Okay, these all, and their ranges are shown over here, 0 to 8 almost. Okay, so petal width is in this range, petal length is in this range, sepal width is in this range, and sepal length is in this range, something like these are the outliers that we can find. Okay, orientation is shown, h means horizontal, by default it will become v, that is vertical, but in previous case we have seen the vertical box plot, now this is horizontal box plot. And by this wide form of the data, we can compare all these elements together, what's the ranges that they carry, whether they are having any outliers or not. It's very easy to do this one by using this particular method here. Now if you want to use the multi-panel categorical data, the categorical data can be visualized using the two plots. Okay, that we can use either a point plot or one more function called as the factor plot. Factor plot draws the categorical plot on a facet grid. Let's see the facet grid, what do you mean by it? Using the kind parameter, we can choose the plot like box plot, violin plot, bar plot, and the strip plot. By default uses the point plot there that we can use in the factor plot. So let's go for the factor plot. So before actually using a factor plot, I am making use of the third data set here called as exercise. Okay, this is the exercise data set that I am having. So information about multiple people are given here. So this is ID of the particular person, what's the diet that it carries, that is low fat or any others, what's the pulse rate that they are having, it's given over here, and for how much time it is calculated, it's given there, and whether it's resting, running or walking, this kind is given over here. So this is what exercise data set is there, whether you're resting, walking or you're running. Based on that, these parameters are identified, pulse rate and few more, which we can see over here. Now let's use the factor plot for this data set here. So load the data set first, and after this sns.factor plot, on x side I am having a time. Okay, so time is mentioned over here, and y side I am having a pulse here. And let's use kind, check this, say this, for 1 minute, 15 minute and 30 minutes, what's the pulse rate? Okay, now when you are resting, okay, so when you are resting, so your pulse rate is almost constant here in it. When you're walking, okay, after 1 minute, after 15 minutes and after 30 minutes, how your pulse rate is changing. Okay, point plot is default used over here. And when you're running, so after 1 minute, after 15 minutes, after 30 minutes, how the pulse rate is changing. So this combination we can do with the help of a facet grid. This is what we call as a facet grid, or we call it as a factor plot. Okay, so combinations of multiple different inputs we can do with this categorical, again continuous, but how many categories and how the variations are there, that we can compare with the help of the okay, here that's what we call as a factor plot. Okay, check this one. Fine. Now when you change the kind, so basically I'm having a kind as point plot here, so I'll changing the kind as the violin plot. Check the violin plot now. See, they are the violin plots. For 1 minute, what's the range? Okay, resting, walking, running. For 15 minutes, what the range? For resting, walking and running. And for 30 minutes, what's the range? So you just can check it. Resting is almost same, resting is almost, but focus on running. For after 1 minute, what's the pulse rate? After 15 minutes and after 30 minutes, what's the pulse rate? That we can find changes with the help of this. So it means that basic, the highest effect in the kind is done by in the time is done by the kind of it. So when resting is actually affecting getting affected, sorry, running is actually getting affected much than that of resting. Okay, that we can identify with the help of this particular violin plot. Now facet grid. So before actually going the facet grid, we'll just okay, just continue. The facet grid forms a matrix of panels defined by row and column by dividing the variables. Trio of panels, a single plot looks like multiple plots. It's very helpful to analyze combinations in two discrete variables. Facet grid, see this one. So let's see the facet grid. So with the help of factor plot, we can create this facet grid. X on time, Y on pulse, here is kind is violin, color is diet. Now see, now here for color I am giving a diet, whether diet is fat or diet is low fat, no fat or low fat. Now see this one, when fats are changing, then how the effect is present. So this plot I am getting for no fat, and this I am getting for low fat. Okay, you can see the effect in this, how effective is that. So if you go for again running is having highest effect over here. So for this case, if you're having low fat, you're not having much pulse rate, okay, in 30 minutes. But if you're having no fat, then see the pulse rate, see too much changes are there. For this case also after 15 minutes also changes. Here also you can see after 15 minutes what the change that we are having when fat and low fat is present. So to categorize it, we are going to have the diet. Okay, so two plots I am going to have it there, and with the help of this again the facet grid visualization is possible. See, one more, here I am using a count plot. Okay, I am using a count plot there. See this, his kind is count. Now, and color I am using deck. So how many decks are there? Total 7 decks are there. Deck A, B, C, D, E, F and G. So in the first deck you can see my parameter is alive. Okay, see whether it's alive or not. Here also color I am using deck and parameter is alive. We just can check this out. Okay, fine. 7 total plots are present here, and this is how the factor plots are possible. Data I am taking deck, not null, means which is not having any nan value, not missing values are present over there. So missing value should not be present, that's why I am using a not null here. Okay, fine. Now let's see the linear relationships. So most of the times we use a data set that contain multiple quantitative variables, and the goal of each analysis is to often relate those variables to each other. This can be done through the regression lines. Now regression we have come across multiple number of times, linear regression, how they are connected together. Now here also we can see this particular line. While building the regression model, we often check for multi-collinearity, where we have to see the correlation between all the combinations of continuous variable, and will take necessary action to remove this multi-collinearity if it is existing. So for regression functions we are having two different plots. There are two different main functions in Seaborn to visualize linear relationship determined through the regression. So first is regression plot, Regplot, and second is lmplot, that is linear model plot. So what's the difference in that? Regplot, it accepts the x and y variables in a variety of formats, including simple numpy arrays, pandas series object, or as reference to variables in the pandas data frame. Okay, and lmplot, it has the data as required parameter, and x and y variable must be specified as strings. The data format is called as long form data. And now see how to use this particular plots here. See this. So I'm using the tips data set here, x total bill, and y side I'm having a tip. Whether they are connected, means whether tip and total bill are linearly connected to each other or not, that we can find by using regplot and lmplot. So see this one, regplot. First is regplot. Okay, and this is the regression line, this one, which is summarizing all together, and this is your second plot, that is lmplot, linear model plot. Okay, total bill against the tip. So they are almost connected. Total bill against the tip, they are connected, and their regression line will be plotted by this particular functions, regplot and lmplot. So this regplot, lmplot. Not much deviations are present over here. That any one of this plot is possible by using this particular method. Okay. Even we can make use of a discrete values also. Okay. Okay. Size against tip. If you are using size against the tip, so size contains 1, 2, 3, 4, 5, and 6. So see this one, size against the tip. Okay. How many people were present? So when 1 was present, 2 was present, 3, 4, 5, 6 were present, then how exactly the deviation or the input output connectivity is there, that also we can visualize by using this particular method of lmplot. So on x side I am having size, okay, and y side I am having a tip, and then you can see this one, how size is affecting the tip given by the particular customers. How many customers were present in the team, whether the tip is changing accordingly or not, that we can find by this. Now let's focus on the facet grid object. Okay, what do you mean by facet grid? The useful approach to explore medium dimensional data is drawing multiple instances of the same plot on the different subsets of your data set. This technique is commonly called as a lattice or trellis plotting, and it is related to the idea of small multiples. Now, how do you use facet grid? See this one. So let's see facet grid. So I'm using the TIFF data set for this particular element here. So let's use tips and use a facet grid df on based on time, and then use the map function. So first of all, you have to create object of facet grid class. So from SNS facet grid, I'm creating the object of it. Okay, and I'm changing multiple parameters with the help of your color is changed based on the parameter time. So two time are there, lunch and dinner. Okay, so based on that we are going to make use of this. Now let's use g.map pld. What you require to print, that is your histograms. pld.histogram I'm going to make use of, and what you have to show, that is tip. Okay, so on x side I'll be having the tip. Okay, so here I'm having a tip given by the particular customer, and this is the value of the respective tip. Okay, so we have separated it according to the time. So time is lunch. So when lunch, while lunch, what's a tip given, and while dinner, how much amount of tip is given. You can check it out, the huge difference that we can find between these two. So huge amount of tip you are getting in dinner rather than using lunch. See this, that's what we can separately find. Here I'm using the map as histogram, and we can find the difference easily between the time of lunch and the dinner. Okay, now there is one more way by which we can draw this data. It's called as a pair grid. So pair grid allows us to draw a grid of subplots using the same plot type to visualize the data. So unlike facet grid, it uses a different pair of variable for each subplot. Generally we call it as a scatter plot matrix. We have seen this pair plot, and now let's see the pair grid. The usage of pair grid is similar to the facet grid. First initialize the grid and then pass to the plotting functions. So let's see the grid here. So for this grid I am using the iris. Okay, so first of all load the data set, and create the object of a pair grid. So pair grid is a class whose object we have to create for a respective data set. So data set is df, and I am passing it here, creating its object and map it. So what I require? Scatter plots. So all the parameters will be connected together, and based on that this pair grid will be formed. So let's see the pair grid. Yes, check it out. These are the pair grids that we require. So 4 parameters: petal length, petal width, sepal length, sepal width, and their scatter plots we can see. It's the same output we have generated from the pair plot also, but there we have defined the class, means output variable. Here we are not given the output variable as species, but their comparison of variations we can see in it. So you can see on diagonal they are same, that's why they are linearly they are shown over there as a diagonal part. Okay, so same way we can make use of. And now I want to change this parameters, diagonals, so we can make use of it. So what I am doing, same thing, I am just making changes there. G dot map diagonal. So on diagonal I require histogram, not the scatter plot. I require scatter plot for others than the diagonal. So let's say this diagonal map I am changing here, and let's see when I am changing the diagonal. So diagonal is this, check, this is histogram which I add in the diagonal, means in sepal length these are the frequencies of ranges, then sepal width, petal length, and petal width. Here I am adding histogram, and remaining others are the scatter plots that we can make use of it by using the map diag and map off diag. Okay. Now, so same case I am making use of it here. Okay, pair grid. So options that we can use here. Okay, and see few more options that we can make use. The last point present over here. Now map upper as the scatter plot, lower as the KDE plot, where I am using the CMap as the blue, and diagonal as the KDE plot, which I am using, not using legend, and LW is equal to 3. Check it out. So their combinations of the graphs are possible here. See this, how it's possible. So lower part I am using KDE plot. So below diagonal these are the kernel density estimation plots. Then above diagonal I am using a scatter plot. Okay, and at diagonal I am using a KDE plot. Okay, this one. How these variations are possible and present, that we can see here. So this is how the pair grids are possible. Basically, as per the requirement of the user, as per the requirement of the program or project that you work on, the data science or machine learning, we need to choose these plots. This is just a demonstration which I have shown in this particular video. So as per your requirement, when you are working on any ML or AI project in data science, so you just have to make sure that which kind of the graph will be useful for you, which kind of the graph will solve your problem, which kind of a graph will give you more information about your data set, or about our prediction, or about your output. Okay, this is how the Seaborn's common functions and common libraries can be used. Seaborn can also be used in combination with the matplotlib. It's a part of practice. You can make use of matplotlib and Seaborn all together to work for data visualization there. If you want to contact with us, and if you have any queries, so the information is there on the presentation with you. Thank you. Thanks a lot.